Hi guys, welcome to my channel. This is the second video. As I promised in my first video, I will be showing you, I will be solving our very first problem in electric circuit. I'm starting with grade 11 question paper, 2019 November. The question 11, there is an electrical circuit there. There's an electrical circuit has got a EMF of the battery is 12 volts. As you can see, the EMF from the battery is 12 volts. And then there is no internal resistance. So I'm starting with grade 11's circuit because there is no internal resistance in what? In grade 11. And the total current is 0.5 amperes. And then we have got a resistor of 8 ohms. And then we have got a what? The resistance X. We don't know that resistance. So as you can see in the screen, in the question paper, I'm sure the question paper now is on your screen. The very first question requires us to state Ohm's law. So Ohm's law states that potential difference across a conductor is directly proportional to the current flowing in the conductor, provided the temperature is constant. Let me say that again. Potential difference across a conductor is directly proportional to the current in the conductor, provided the temperature is constant. So if the temperature is constant, it also implies that the voltage, the resistance is what? Is constant. So this is Ohm's law. So as you can see, I'm going to solve the very second question. The second question requires us to determine the resistance R. So we are going to use Ohm's law to determine the resistance of that resistor. So as we can see here, we have got as we can see here, we have got the total voltage from the battery. We are going to use Ohm's law to solve this problem. We have got voltage from the battery is 12 V. The total current from the battery is what? Is 0.5 amperes, and we are looking for what? For resistance. So using Ohm's law, we are going to say V, which is the voltage, is equals to I R. So R, this is the total current. This is the total. This is the total current, total resistance for the whole circuit. Remember that total resistance is made up of what? Of the two resistors R according to R 8 ohms and X. So we don't know that resistance. We are looking for it. So we can say V voltage is what? Is 12 volts. And then we have got I, the current 0.5, and then here we've got what? A total resistance. Total resistance is given by total resistance R is given by 8 ohms plus Rx. I'm going to call that resistance with the unknown resistance what? Rx. So as we proceed, we have got R. We've got R. Remember, R is given by this because the resistors are in what? Are in series. So as we proceed, we have got 12 is equals to 0.5 R divided by 0.5 divided by 0.5, and then we have got R is given by R, which is the resistance in this case will be given by 24 what? Ohms. Then we know that R is equal to this. So let us substitute this here. Then we have got 24 ohms is equal to 8 ohms is plus Rx. Then we have got 24 ohms minus 8 ohms is equals to Rx. Therefore, Rx is given by 24 minus 8, which is what? 16 ohms. So Rx, the resistance of unknown resistor, is what? Is 16 ohms. The question is from grade 11. So I want you to be ready, so that if you start with grade 11 questions, you should be able to solve grade 12 problems. So that's it for now. I'm going to introduce the next problem. Thank you for watching. Hopefully this will be the last question in grade 11. So we have got an electrical circuit. As you can see there, the EMF of the battery is 12. So you don't have to worry about This is still grade 11 question paper 11.2, November 2015. So the internal resistance, the EMF of the cell, EMF or just voltage is what is 12 V. So we don't have to worry about internal what? Internal resistance is still negligible. So we've got the switch S is opened. Switch S is opened. Then as we can see here that now the first question, which was 11.21, requires us to give the voltage across the 4 ohms resistor. We have to determine what is the voltage across the 4 ohm resistor. I'm sure the question paper is appearing on your screen as you are supposed to be able to see. Then we have got the voltage across the 4 ohm resistor. This is the voltage from the battery. So remember what happens when these resistors here, they are in what? They are in parallel. So 4 ohm resistor is in parallel with 16 ohm resistor and also in parallel with these two resistors here. So now remember what happens when resistors are in parallel. They divide the current, but voltage stays the same. It means that the voltage across these two resistors is 12 V. Voltage across 16 ohm resistor is 12 V. Voltage across 4 ohm resistor is 12 V. So the voltage here is 12 V because they are all in what? They are all in parallel. So that is what we have, and this is only the set of resistors we have in this circuit. So secondly, the second problem we have to determine here is the reading on ammeter A. We have to determine the reading on ammeter A. And let me just see, this is the reading on the ammeter A. So that is correct. I wanted to verify the question. So reading on ammeter A will be given by. Now we have to firstly determine the resistance of the parallel section. We know the voltage of these resistors. We know the voltage here is what? V is 12 V because the resistors are in what? Are in parallel. So let us determine that resistance. Now we are going to start by saying, since they are in parallel and they just two, resistance of the parallel section is given by R1 times R2 and R1 plus R2. Then we have got R parallel is given by R1, let it be 16 times 4. Then we have got 16 plus 4. So let us see what we get. For that, I'm going to just have to quickly use my calculator here so that we do not waste much time. We have got 16 times 4, and then we have got 16 plus, let us see, 16 plus 4. The answer is, for the resistance, is 3.2 ohms. That is the first thing. We have just determined the resistance of the parallel section. So now we have to, because this ammeter is aligned with this section, we have determined its resistance of this path only. And then now we know the voltage of that path. Voltage is given by 12 V. Then from there, we are going to apply Ohm's law. Ohm's law, V is equals to I times R. So we have got can just call that one IA, the current or the reading on the ammeter is denoted by A. Then we have got IA is given by V over R. So that is what we have. Then from there we have got the voltage is 12 divided by what? 3.2. Then we have got IA is given by, let me just quickly use my calculator. We have got 12 divided by what? 3.2. 12 divided by 3.2. So let us see the answer here. The answer is 3.75 amperes. So that's the reading on this ammeter. It will read 3.75 amperes. So that is the reading on that ammeter. So that is what we have. But note that this is the current passing through this section only, but not the total current in the circuit. So that was the second question from this this circuit diagram. Now we need to find this is the question 11.2.3. It requires us to find the energy dissipated by this resistor, 12 ohm resistor. So in 2 minutes, how much energy has been dissipated by this resistor. So what I can assure you about this question is that they love this question. Even in grade 12, they ask the very same question. So if we go to solve more grade 12 problems with this background, I'm sure that we will be in good hands. So, or we are making a very good start. So let us see. 2 minutes. So first of all, the resistance is 12 ohm, and then time is 2 minutes. 2 times 60. 2 times 60. We have got 120 seconds. Remember, our time always has to be in what? In seconds. So we've got 120 seconds. So look, energy is usually represented by work. It's given by let us say voltage times what? Times I, which is current, times change in time. We've got time, we've got voltage, we've got current. Now let me just eliminate one of these. So from Ohm's law, we know that V is equals to I over R. I want to eliminate the resistance. So I mean the voltage, so that we can use this resistance, the resistance that is known can be useful. So we are going to say energy is given by where there is V, I'm going to put I, R, and then we've got another I, and then delta T, and then we've got energy is given by I squared times resistance times change in what? Change in time. So the question was worth 5 marks. So we don't know the current passing through this resistor. We really don't know the current passing through what? This resistor. Now we are going to determine the current passing through this resistor. Let us see how we go about that, so that we can calculate what? Our energy, because we know the resistance. The resistance is 12 ohms. We know the time, energy dissipated in what? In 2 minutes, which is equal to what? To 120 seconds. So I'm going to create some space here by erasing this. So we have got to calculate the current passing through this component. Remember, this component, two resistors are in series, so the current is the same. So I'm going to calculate the current, that resistance of this component, the two components. Resistance is going to be given by R is equals to V over I. You know that the resistance R of these two components, it would be since they are in series with each other, 12 ohms, 12 ohm plus 8 ohm, which is equal to 20 ohms. So the resistance of these two resistors is equal to 20 ohms. I have got R is equal to 20 ohms. Then we have got voltage. Voltage of this resistor is equal to what? These two resistors is equal to 12 volts. Then I can just rearrange this and say I is equals to so I'm just swapping the two, is equals to voltage over resistance. Then from there we have got I is equals to voltage. Voltage is equal to 12 over resistance. Our resistance is 20. The resistance of this section is 20. We've got a 20, which is equal to, let us say I is given by, the current of this section only is given by 20 divided by 12 divided by 20. I'm going to divide 12 by 20. 12 by 20. Let us see what we get. We get 0.6 amperes. So the current through this section is equal to 0.6 amperes. So since we have got the current, we are going through all this trouble so that we can find the current passing through this section. So now we have got the current is 0.6. Our current is 0.6. We know our resistance is 12 ohms. So the current passing through this resistor is 0.6 amperes. And the current also passing through here is 0.6 amperes. So now we say energy is given by the current is 0.6 amperes squared times 12 times what? 120. So let us see what we get. I'm just quickly going to calculate that. so that we can get our answer. Then we have got open brackets, 0.6 squared, then 0.6 squared times what? Times 12 times what? 120 seconds, and then we have got what we have. Our answer is 518.4 joules. The units of energy is joules, and the units are very, very important. The question was worth 5 marks, and we had to firstly find the current passing through this section, and we had successfully done that. So this is how we solve this problem. And in my next videos, I will start dealing with grade 12 problems, because I am sure now that you have got this background and you are in good hands. Thank you.